My name is Michael Weiss-Malik. It's my pleasure to introduce our guest speaker today, Josh Knauer. There's a lot of data in the world, but not all of it is accessible, and he's going to talk about some solutions to that.
Great. Thank you very much, Michael, and thank you to everybody who took some time today to come hear me talk. Wanted to let you know just a little bit of what's going to happen during this talk. I know a lot of you are here to, you were sold on this as a conservation data talk, which it will be. But we're going to talk about some basic underlying technology stuff that we've been doing and lay some groundwork before we get to demo the new website that will be unveiled here, which is kind of exciting. I'm going to be joined by a few of my colleagues. Michael Higgins is the CTO of Ryza Labs, and Dr. Tasha Commandant, who is a scientist, conservation scientist with the Conservation Biology Institute. So just jumping right in, I wanted to give you a quick background on who we are. Ryza Labs is a Pittsburgh-based company with, as everything in Pittsburgh, related technology, deep Carnegie Mellon roots. Our focus and mission is developing software that helps communities unite their data. And the problem that we're trying to address is that many people who make decisions in communities and nonprofit organizations and the government sector don't have all the data that they need in order it accessible in one place for them to be able to make better decisions. And so part of our mission also is preserving open access to public data. We're very concerned about the erosion of the public data space, and that's one of the issues that we're really trying to, as a core mission of our company, to try to help with. And we've developed software specifically on top of an architecture called the Information Commons. And I'm going to take a little bit of time to talk about the Information Commons. It is a peer-to-peer database system developed by a company in Pittsburgh, our parent company, called Maya Design. And what's interesting about it from my perspective is that it's an autonomous system, so that every peer that operates in the peer system is completely autonomous. It's not owned by, doesn't have to be owned by the same entity. And you have incredible amounts of replication of data that take place. So any data object that goes into one peer is automatically replicated out to n number of other peers. And so that allows for the ability to preserve a lot of, in the open data space, the public domain, basically. So if a server goes down, it doesn't really matter. You can get the data somewhere else. And we've also been working quite hard on distributed indexing algorithms so that you can actually search across peers. You don't have to have all the data in one peer specifically to be able to query and find your information. And it's an open architecture. It's not as open as we might like in terms of documentation. We've been a little slow on that, but if you go to our website, I'll provide a URL at the end. You can read some of the papers that we've published about the architecture itself and how it works. So you saw cloud on the screen, and I knew coming here, that might lead to a bunch of questions. So everyone has a cloud, and I'm sure you've had other people here talking about their clouds and whatnot. It's certainly cloudy days these days on the internet, and what I want to do is just outline a little bit of how what we're doing is a little bit different, not necessarily better or worse, just different than some of the other cloud architectures that you see. So I took a risk by including Google in this, just coming into your camp and telling you what your systems are about. But this is just my impersonation of what's going on in the world. So Amazon and IBM, and Google, the types of clouds we're talking about are there's computing clouds, obviously, with node network type stuff, and also Amazon and Google with storage and web services in a cloud, quote unquote. These systems are to me, seem to be a low-level architecture about, data isn't necessarily shared across customers. It tends to be siloed. So if I upload my data, you upload yours. There's no guarantee that those two data sets I can query, for example, across both of those data sets and get information. And frequently, developers have to build their own tools if you want to get access to the information. And these clouds tend to be controlled by one corporation at a time. You're either buying into the Amazon system or the Google system or anybody else's. There's other types of clouds out there too that are more specific in purpose. So Flickr and YouTube and things like that. Those are really about aggregating information at a higher level. I want to post my photos on someplace or a video or whatever, and information is automatically shared by default. Other people can tag your data and comment on them. They can put them in their own collections, things like that. But the tools are a little bit more limited to savvy programmers. And once again, the cloud is controlled by one corporation at a time. It's very difficult to be able to do queries across multiple types of these systems that are out there, other than through web service type architectures. I have a question already. This is exciting.
I'm sure you're getting to this, but I want to ask it anyway. So when you say the cloud is controlled at the physical level of storing the data, it's not controlled at the logical level of I can store on Amazon or Google 100 databases.
That's right.
Very different schemas.
The control is really just ownership of the system that you're on, not necessarily. I'm not making any claims about the ownership of the data, and I really do want to be clear. I'm not coming in here saying that these are bad. I'm just trying to outline, to set up some differentiation between what we're doing as well. When I do talk about the information commons and sort of what we're focused on and our goal out of what we're doing, we are specifically focused on trying to help. It's designed specifically for the public interest in mind. And once again, not that anyone else's isn't, but just that this is our goal. And it is a low-level architecture of data storage, and I'll get to that in a second. By default, all data is shared. It's actually quite hard not to share your information across the different nodes that you put in, and that's on purpose. Once again, because it's a low-level architecture, you need to build your own tools to be able to get access to it. And each node can be independently owned and operated, basically. There does not have to be any common ownership across the different nodes that you have. The base architecture that it's built on is fairly commonplace in terms of it's just tuples. It's attribute value pairs that are bundled together with UUIDs. And these are the currency, basically, that get traded around in the peer network that we've been developing. And so I just have a very simple example here of one. We call these U-forms, but basically, just attribute value pairs. The values can be just about anything you want, including the UUID of another U-form, of course, and so you can start linking them together. And that's, for example, how we deal with indexing and other types of issues. I wanted to present this specifically just to present a taste, basically, of the lower underlying architecture of what we're doing, so you can get a feel sort of where our roots are coming from. But I really do want to pretty quickly move on into just understanding what we're doing with this architecture, which is, I think, just as interesting, hopefully. So before I do move on, though, I just want to acknowledge when you're trying to develop a distributed peer-to-peer information storage system, there's lots of challenges that are involved. And we recognize these. We've addressed some of them, and many others are ongoing research projects that we and now some other folks are starting to address. OK. So specifically, what we do as a company, as Ryza, I just want to spend a little bit of time talking about this, is that we help people get their data into the commons. We help them set up nodes if they want our help doing so. And then we build tools that allow people to get the data out of the commons in any number of different formats that they want. So starting up at the top, we provide a web services layer, basically, where you can make queries into the commons and get information out into one of any number of different formats that you want out. And that allows many of the nonprofit organizations and some of our government agencies that we're working with to build their own websites, right, and to build their own interfaces to the commons. We also support the ability to get your data out into many sort of standard application formats. So KML, which I just learned today, is now or soon to be a standard, which is very exciting. And Esri shapefile format. A lot of the data we deal with is place-based data. So it's about where things are in a community. So geographic interoperability is quite important. But also getting your data out. Many of the folks we deal with are really they're not highly technical. They don't work with GIS systems at all. They use Excel or some other type of package to do data analysis. And so we have to support outputs into those formats. And of course, we try to keep up with all the different flavors of RSS and different types of standards like that that people need access to. What I'm going to be talking about today is this specific product that we have. I want to touch on another one that we've been working on for several years. And it's a product called Community Catalog. It's a very, very sort of simple tool for communities to collaboratively track assets in their community. And how it's used, for example, there's a screenshot here from New Jersey. We're working with the United Way of New Jersey to help keep track of all the social service agencies and the services that they provide throughout the state. So they can do specialized searches to find their information. We have other folks using it for outdoor recreation catalogs basically within their communities. And the idea is that there are several thousand agencies that are their information is tracked through that New Jersey site, for example. Each one of those agencies can come in and edit their own information in a very simple, easy way. And they're now then able to have all the information available to human service professionals throughout the state. It's something that is a very basic application, but it's one that at a community level, when you're dealing with in the public sector, these are the types of tools that they feel that they don't have adequate access to, where there's consistency of their data across the community. Because all the data is stored in the information commons, no matter how anyone accesses the information, and regardless of which tool they use to access the data, they're always getting the same piece of information about, like, for example, the phone number or location of an agency, which is very, very important in terms of referrals. What we're going to focus on today, though, is a new product that we've developed called Community Insight. And it's a bit more of an advanced tool. It's meant for people who are experts in their domains, who have some large amount of data that they want to analyze and understand better. And they may want to see not just their data, but other people's data as well in context. So it's a tool for sharing data among those experts. And we expect, once it's made public, that the general public will access it as well. And we know that already, for example, in Databasin, which is the site I'll be talking about today, we're already starting to see scientists starting to interact, for example, with advocates in the conservation science world in a way that they've not been able to do before because of the platform that they have access to. So I'm going to move on now and talk about the Databasin project. But I just wanted to give you a basic framework of where we're at. In terms of how we're trying to deal with this information commons and get information out of it. So the Databasin project specifically is a collaboration actually that started several years ago. The Wilberforce Foundation is a large conservation science funding foundation based out of Seattle. They have, I think, 150 different grantees that they fund every year. And they fund mostly on the science side of things. They're not necessarily, they fund a little bit on the advocacy side as well, but it's really about how to use science in your advocacy. That's their area of focus. And one of the problems that they had is that they kept funding different data storage systems and different analysis systems for each of their organizations. And it was getting kind of ridiculous. Their organizations weren't collaborating with each other. They were collecting data, overlapping data about similar areas. The common problems, I think, that we tend to see a lot in the public sector. And the Conservation Biology Institute, who is a grantee of the Wilberforce Foundation, was chosen to sort of work with us to, because they are an organization, and Tasha, who will be speaking a little bit, works for them. They're an organization that helps organizations, grassroots organizations, interpret and understand the context of the science that's being collected and how it can be used in their advocacy work. They do that a lot through GIS applications, a lot of Esri usage and things like that. But they also have a problem with delivery of their end product. How they get maps to end users, for example, is an issue. So the other problems that we ran into when we decided, okay, wouldn't it be great if all 150 of these organizations that Wilberforce funds use the same system and everybody just shared their data and everybody's problems would be solved? It turns out it's, as we all probably realize, is not that easy. It's very difficult for scientists and advocates to communicate. It's one of the dirty little secrets in the conservation world. They tend to speak completely past each other. We see this, I'm sure, in our everyday lives when you sometimes put engineers and designers together or other types of people from different disciplines. They speak different languages. And for them, there were no really easy solutions for publishing, searching, and visualizing of the data that they wanted to do in a way that they wanted to do. And scientists specifically have a concern that their data would be misused. And because of the way the data had been stored and passed around in the past, basically in other attempts that have been made, they felt that their data was being misused, and that was a big concern. And so the concept of incentivizing, the technology part of this isn't actually the huge challenge. It's incentivizing people to actually participate in a system like this. And so as a design challenge for us, it was how do we correct this problem? How do we build technology that actually allows for these folks to be incentivized in a positive way not just a funder telling them to do something, but actually them wanting to participate. And really what we learned when we started looking into the issue is that most of the prior solutions that had been created in this space for the conservation world specifically, they failed spectacularly. Millions of dollars spent on projects, and all of a sudden nobody used them. They turned into ghost towns. And so what I'm going to do is spend a little time just talking you through very quickly the process that we went through, expose you a little bit to the process that we went through to get to the point where we are now. And it really starts with understanding the users. We went out and interviewed dozens of people in the conservation science world, both from the advocacy side and the science side. And we started off with the premise that there were a couple of key user bases. There was these advocates, and we always create personas, or basically, the Holly Teal doesn't actually exist, and if she does, I apologize to her now, but this person is not named Holly Teal that's up here. And basically what we did is we created a profile based on the aggregate information that we started collecting from many of the different people that we talked to who were conservation advocates. And we looked into what do they do on a daily basis, what are their motivations, how is it that we could get the Hollies of the world to start acting. We created some user scenarios, some mock user scenarios where we were just experimenting with different ideas. And we started coming up with other folks, other personas. Fred is a staff scientist at a conservation organization. We did the same type of thing with him. And Dr. Joe Smith was the academic, the one who's doing a lot of the research that's in the ivory tower that is publish or perish, et cetera. And at this point, we ran into a problem, which is that we weren't quite sure how we could motivate an academic like Dr. Joe Smith to actually unload some of the data that he had, because he was a treasure trove of information that a lot of the advocates needed access to. And what happened is when we were talking to users, and this is something that we really try to focus on in terms of understanding how people use public data, when we actually started talking to people about it, we discovered a new person, a new persona. And so we gave her the name Dr. Helen Rhiza, and basically it turned out that by designing our system a little bit to appeal to her. She's sort of a maverick academic, if you will, somebody who actually likes to publish and got into the study of what she's doing in order to help advocacy work happen. So it's not that just that she likes to publish, but she actually is okay about blogging about her data, for example. She's probably the type of academic that is using Google Earth to display their data, just as one example. I have a question, which is fun. Oh, so the question is, why didn't Dr. Joe Smith want to share his data, basically? Publishing is just fine. It's sharing data before publication, and even sometimes after publication because of the competition that exists in the academic space. This persona specifically exists purely in the academic space for publishing and grant money and part of the game that exists. And the subtle difference between a Helen and a Joe basically is Helen is willing to let go a little bit. Like she's willing to put some of her data out there before it actually maybe gets published or even peer reviewed in publications. She doesn't have tenure, and he does, actually. In the interviews that we were doing with people, there is a breed of academic that we've, in the conservation. So, for example, she also belongs to the Society for Conservation Biology, which is a real organization. And it was actually through that organization that we tended to find people like her, just as an example. So we were able to sort of uncover this type of person that, to be honest, none of us thought existed when we first started. We didn't know that there was somebody other than the persona of this Joe fella. So basically, what we ended up doing was trying to map all these different motivations, these competing sometimes motivations that we found in this space. And what's interesting is we've applied this in several other areas, and we found that this is a general trend that's true. This blue space that's here is sort of where the types of users that we're building the system for. This is who we're targeting in the beginning with the system. We hope to get them as users. And we've got Helen here and Fred. And what we did is we graphed them on axes. So the x-axis on that side is low scientific knowledge, and over here is higher scientific knowledge. And then on the y-axis, the higher up you go, the more quote-unquote objective people are, and I have to put scary quotes around that just because there's lots of versions of objective. But specifically in the case of conservation advocacy, towards the bottom on the y-axis, Holly has an agenda, right? She's out to prove that something should be stopped, that something should be saved, that something's going to happen, and she has to convince people out that direction that to take some form of action. If it's a reporter, she wants an article written about it. If it's the public, she wants them to write a letter. If it's a lawyer, it's to help her in court while she's suing somebody. There's any number of different sort of motivators. And in order to gain their credibility, and once again, we learned this by talking to lots of Hollies, she needs to be able to have access to the information, the knowledge that's in these folks' heads. Okay, so I've now sort of talked about our exploration in a fairly academic and sort of consultancy kind of way in terms of what we did for a client. What I'd like to do is actually introduce Dr. Tasha Commandant at this point to talk. She's going to help lead us through most of the rest of the demonstration. I'll drive the computer a little bit. Because she's actually, when I first met Tasha, I actually said to her at the time, "You're a Fred." And she didn't really quite get what I was talking about, but now hopefully she does. And I wanted just for you to talk a little bit about some of your experiences.
Thanks, Josh. What I want to do really is to try to move this out of the personas and move it into kind of the real problem, again, that the conservation field is facing, which is this inability to get easy access to information to make evidence-based decisions, essentially. So I fit in between the Fred and Helen thing, and one thing I wanted to add to your question was, I think the Helens of the world are thinking about applied problems, and so they're realizing that you need to share information in order to solve real-world problems, whereas much of the rest of the sort of older, more ivory tower is about solving basic research questions. So I'd like to move straight into the demo and show how this site is helping us share information better, connect with other people, build links between Hollies and Freds of the world. So let's move right into the demo.
I'm just, I've lost track of which one was Fred was.
Sorry.
Which was Fred?
Okay, Fred is a staff scientist at a conservation organization. So for example, I've been working for the past 4 years at the chief science team at the Nature Conservancy. So I fall into the Fred group. I decided to leave academics and move towards solving more applied conservation problems. So that's why Fred is in the staff science role. And then Holly is the campaign manager at a nonprofit organization that may have a very specific issue that they're working on or a specific geography, for example.
Okay, so we're going to get to that in 2 seconds. Just one quick thing, just so you understand where we are in this process. We just finished the software and to our client basically a week or so ago. So it's in a private testing phase right now, 10 to 15 users right now. We'll soon be at 50 to 150 users in May, and that's a point at which if folks in the audience here are interested perhaps in joining us in testing the software, it's Tasha's decision to decide, but I think you could probably ask her nicely, and she might be interested in that. And then we'll have a public release in July. The idea is to get this out to the public as quickly as possible, but we need to make sure that the feedback that we're getting from people, we're meeting the actual design need that we set out in the first place. And one of the comments I just want to, when we showed this to some folks at a science conference last week or two, whenever it was, one of the comments we got, oh, it's like Flickr for data, which for us actually was kind of interesting as a reaction. It's not exactly that, but if that's the what people thought of it, kind of cool. Okay, so I'm going to flip over now to the web, and we will go into a live demonstration mode. And Tasha, take it away.
Okay. We've built a take the tour function at the beginning where it'll kind of lead you through how you can find the data that you're looking for. So you can search by specific geographies, you can search by keywords, and then you're able to access these data sets and visualize them in new ways. So there's many, like my organization, the Conservation Biology Institute, we've recognized this problem and we've been aggregating data on websites for a while. We have one called the Boreal Information Center for about forests in Canada. But you go on the website and all you can do is download stuff. So for the Hollies, the campaign managers of the world, they don't necessarily know what to do with those type of files and they don't know how to connect with the people who generated that data. So these tools basically allow you to map and graph and chart in new ways that are very intuitive and user-friendly. Like myself, for example, I'm not a GIS analyst, so I often just I'm not able to use spatial components in the types of analyses that I'm doing, but now I have a tool where I can easily visualize.
Just very quickly, one of the key components of how we get people to participate, especially folks who have data, who are the holders of data, is this concept of trust. Basically permanently attaching, we call it tattooing the data basically, so that metadata never gets separated from the data itself. And so that you can always know when you're looking at a visualization that somebody's created, what are the source data sets, who created those source data sets, how do I contact them, things like that. Those are things that we've learned from talking to the folks are just exceptionally important. Okay, so that's the tour. Everyone can go look at that if you go to databasin.org. If you're in the crowd right now, just hold off for a second while we do the demo, and then we'll be happy to let you at it.
So I've gone on and built a series of examples that hopefully will take you from just looking at raw data sets that are out there to then looking at analyses. So I think this is another added innovation feature that scientific organizations like Conservation Biology Institute will spend a lot of time, building criteria to help us prioritize certain areas for conservation action. So we'll go through a whole series of analyses, but there's not an easy way to communicate with different groups on that type of analysis. So there's added value in these data sets. So I'm going to walk through an example here where this is the Tongass National Forest up in Alaska. And we had some data that came from between pre-1960 roads that were built for logging. So there's a series I'm going to go through that show that the development of roads during each decade. There should be.
They're coming.
They're coming. Okay. So you can see I've built a time sequence of road development just to visually show the impact of humans on the landscape.
Just to be clear, what Tasha did, she created these maps from scratch, taking the data sets that other people loaded onto the system, and then created these snapshots of them, and put them together in a slideshow. And a slideshow has a unique identity and can be shared around the internet so that somebody could link to it. And this is a live version of that map, basically, that you can see the presentation as Tasha intended it to appear.
And so then people's analyses can actually stay in the system too, because often other solutions where you pull the data off and do an analysis on your desktop, it's not adding value to the community at large. So now we're here in the 1990s, and you can see the development of roads. And then lastly, I overlaid on top of that, the clear cuts that came along with those type of roads. So I think this can tell you can use this to tell a compelling story to your congressman. You can say, look, during your lifetime, this has been the change on the landscape in this area. So the next example is, it's a more, you can use this to build much more complicated visualizations where you're for the first time able to take data from a bunch of different people and graph it all on one map. So here I've laid over, or Jeff, our colleague, actually built this one. He laid over the oil mines that are shown here in these red squares and overlaid that with important fish-bearing streams, seabird nesting habitats, and then in green you can see two different types of protected lands, the darker green being the highly protected lands, and then kind of going towards a lower level of protection. But so you can see, you can start to bring in multiple types of data to tell the story that you're using.
And the idea is this slideshow is just a quick overview of the data, and what I did was just clicked into it basically, so I can see what Jeff intended when he created the snapshot that Tasha then took and put into her slideshow to sort of communicate. And we can see the data sets that were used in it and the visualization styles and all the rest. You will note, of course, I hope it's apparent to everyone here, we should have mentioned it in the beginning, but we are using the Google API to build these maps and all of these tools. We've obviously added some of our own mojo to it, but the base functionality that we have here is coming out of the Google API. So thank you to everyone who here has been working on it.
And one feature that's really amazing from my perspective is, if I find a snapshot where someone's already interpreted did a problem or generated an analysis, when I click on that, I can't modify their view of the world, but I can save it as, and what gets pulled up with it is all the data sets. So I don't have to then go search and try to recreate what they've done. This is our
colleagues having fun
our,
with comments.
So another feature is this comment. And you can draw an area around if I know that actually this protected area actually is in the wrong spot, I can make a comment to someone. So it's a way people can communicate.
So it's taking visual commenting to that exist in some systems like Flickr or whatever, where you can just draw a box around things. This is allowing experts or non-experts to annotate their own visualizations or other people's. Anyone who comes to this snapshot is able to add a visual comment, and we keep track, obviously, of who does it and when, and we also have other forms of commenting that can take place, including ratings. And just one quick comment in terms of the trust issue. These are the types of features that people tend to like. If, for example, if I'm a scientist and I generated one of these data sets, I can see that somebody created a snapshot using my data set because of the way that we've built the system. I can go to the snapshot that was created as a result. That's their public sort of assertion about my data in comparison to others. And maybe I can draw a little box and say, you know what, you missed something here. This isn't what I intended, or this is what I intended.
So I want to make sure I understand this, that there are essentially, if there's somebody's visualization or Jeff's visualization, I can either snapshot it, which is the visualization exactly as it is now, or I can essentially do some sort of a live link to it.
Yes.
So that
and
it changes his visualization, I can say, but on April 15th, this is what it looked like.
Actually, visualizations are snapshots in time. So Jeff actually can't change this exact snapshot with a unique identifier that is unique. What he can do, or what anyone can come along and do, is if I go to the action menu up here, which is just a little user interface thing that we wrote, I can go in and click Edit Visualization. What that does is it creates a copy of Jeff's visualization.
And it pulls up the data.
And it pulls up all the data. And I basically start my visualization session, which we'll show you in a second, exactly where Jeff left off. But what happens is that if I make a subsequent product out of it, a snapshot of it, that snapshot will have attached to it that it's based on this snapshot from Jeff. So once again, you have citation basically built into the system, which once again, we're getting some pretty positive feedback from folks that, for once, if I put my data out there, I actually get credit for it. But that's one of the big pieces of feedback we're starting to hear already.
Yeah.
That sounds really great and awesome. I'm just wondering what happens at some point if Jeff realizes that he made a mistake originally. Is he a way to propagate that forward to everybody who might have a copy, and at least let them know they should be facing a new version?
Yes, and I'll give a qualified yes that by the time this goes public, it's a feature where we're in the process of working on it as we speak, but the idea is to have versioning of a snapshot. The fact that he will never be able to change his old snapshot, that will always exist, but if you went to it, and we're still working out the UI tweaks on this, but basically there will be some sort of indicator that you're not looking at the newest version of the snapshot. You may also do that with data sets themselves, because data sets are also immutable in sort of our world. In this systems world, I should actually say. We don't allow changes of data sets, so that once again, if you've created a visualization based on somebody's upload of a data set, it can't get changed out from under you.
Could you repeat the question?
Oh, I apologize. Yes, so the question was asking about
Correcting data.
Yeah, correcting data. What if Jeff wanted to correct this visualization and create a new version of it, basically? How would it then get propagated out to other folks? Okay.
So we're going to show you one of the other features. So much of it is around visualizing geographic information mapping. So we also have a feature where you can chart things as well. And so you can interchangeably go from a map to a chart if the data format is comparable.
This is a data set actually that came in Esri shapefile format, and we're just allowing people to flip it from a map visualization to a chart just so they can see.
And what we're showing here
there.
is population size, it's very basic, by state. And then there's added features where you can adjust the size if you add on another variable. If you want to say, well, how big are farms in Iowa versus the size in California. So there's some complex features in the
It's
in the
added
charting.
dimensions of the visualization, basically. So, for example, you can use color and size of the dots, and we're just getting started with the charting side of it, but that allow you you can visualize other dimensions, attributes within the data set. And you can also do this with multiple data sets, but they need to share attribute names across them, and the mapping across those is something that further down the road we're looking at, so that you can actually take two completely different data sets that may be about the same thing and describe their data in different ways and actually link them together. Complex visualizations based on multiple data sets is a big challenge, obviously. There's a lot of issues around identity and all kinds of other issues that we've been dealing with. But we just wanted to show you an example of the charting side of things as well.
This is an example from your neighborhood. It's an analysis that the Conservation Biology Institute did for Save the Redwoods. And so this is mapping out redwoods by basin. And it's an example, as I was mentioning earlier, about showing an analysis. So there were 9 different criteria that went into deciding whether this region was a high-value redwood area. Is there old growth there? Are there roads through it? What's the proximity like? Do the roads cross streams? So we set out, we're going to do an analysis. We're going to base our priorities on, this criteria. And so now we have a way to communicate visually about different types of priority setting schemes. So basically the darker red ones are high value redwood conservation areas.
Just a couple of quick, I'm doing like these UI notes, and I apologize while Tasha's talking about the science, which is great. But just so you realize, we can go in and I can click on this data set, and it'll bring me to the concept in the information commons about this data set and how we're visualizing it. This is all of the metadata from, we as a first pass, the conservation science community identified to us that the FGDC metadata standard was very important to them. And please don't, it's Federal Geospatial Data something or other. I always forget what the last C is for, but it's a great, it's a standard for metadata. And basically, we support all the attributes of it so they can be displayed if there are variables associated with it. And it allows for scientists, people to understand the history. You can go in here and read about everything actually that Tasha just
You can actually
sort of
go
said.
in and look at the report, since we stuck the URL in for the report. So.
And see a sample of the data typing and things like that. Realize that all the things, the snapshots and the data sets and people as well, we could click through and go, learn about this guy, Brendan Ward, and click through to him. You can rate people, you can comment on data sets, you can always just, once again, it's part of this trying to distribute out trust so that people can start, similar to the way they would on rating products online, you can go and start making assertions about the objects that you find in the system.
So the types of questions, you can then, because often different conservation organizations set priorities in different ways. So you could actually use this tool to look at how, the Nature Conservancy views this area versus another. So it's the first time you can really visualize different types of priority setting schemes. And then you can ask questions bringing in different data sets. So what I wanted to look at then was, okay, well, if this is our high priority in darker red here for redwood habitat, well, is that area protected or not already? So then I can go in and search on California Protected Area Database, and
so what I've done in order for that to happen is Tasha now is taking somebody else's visualization. Actually, technically that one was hers, but and taking it a step further. I'm logged in as myself. Actually, it's just important just to understand, that we're all sharing these bits of information back and forth. So we've gone as Josh to this data set, the snapshot, and we can now edit the visuals and make a copy of it and make some new query that we'd like to have. And you were just asking for the California pad, so I'm going to add in another data set by doing a quick search for it within the system. This is the first data set happens to be the one that we want. This is a data set that was put in by the Conservation Biology Institute based on data, Tasha, correct, from the USGS, I think?
Yes.
And so now I have the ability to set up and build the map that I want to see. So I can choose any attribute from the system, and
so we're going to pick one called GapCat.
Thank you.
Which is It's a ranking system between most highly protected wilderness area to private lands where people can do whatever they choose. So there's kind of 4 main categories. So we're going to look at categories below 3, which essentially have some level of protection.
And what I'm going to do is make it, I can choose how I want it to look. Part of the storytelling aspect of this for a novice user who's not a map generator is we heard this a lot. I want the map to look pretty, or I want it to look the way I want it to look, to reflect my sort of opinions. So I'm just going to randomly pick some colors here for the outline, and I'll set the opacity. So what it's going to do, just to be clear, when I click OK, I've set up a query of the system that's looking through an entire data set that is the California Protected Areas Database. It's going to only return the shapes that have a gap cat, which is just an attribute in the system, less than 3. And so I'll run the query by refreshing the map. And so it's just now, Tasha can explain what we're looking at. Yeah.
So if you also have the ability to then click on and off between, so if you want to compare. So there were some high value areas in darker red. So, and then if you overlay on the map again, you can see that some of the main focus already areas of protection overlay those important habitat areas. So there's all kinds of ways you can bring in different types of questions that you might have, and it's a very flexible, user-friendly tool. Especially, I can say that not having been a GIS analyst in the past, it's a whole new realm that I can go into. And then the last one we wanted to do was an example for climate change.
Yep. So which search would you like me to do?
Climate.
Okay.
And that one on top, the current vegetation distribution.
By the way, just for the more expert users, one of the things that we threw in here was the ability to just immediately download the results here, this data set, as either an Esri shapefile or directly into KML. So if I was to download into KML right now, it would open up Google Earth and we would see it. Or if I was to do it as a shapefile, it would open up Esri ArcView or whatever and would allow me to get the data that way. Other data formats like that are coming soon. We're just we keep adding more. But these are the 2 most requested ones. But what we're going to do is visualize it within the tool itself.
Okay, so choose class. The class is characteristics. So we just broke it down into really coarse vegetation categories like forest, shrubland, savanna, desert, just very basic, kind of easy to understand. So the light pink is forested regions currently. This is just an existing vegetation map. Savannas, deserts, you can see down near Arizona. It includes, there's 7 different classes that this shows just the current map. So, yes?
Can we see the legend? Can we add a legend? Because you described what we see, but that would be nice.
Yeah, we have that right on the very top of the, the list, yes. I mean, right now you can click on it, it'll say class 1, but that doesn't mean anything. You have to go into the metadata where we put class 1 equals forest, class 2. So, yes.
You very keenly pointed out one of the sort of wires sticking out of the demo at this point,
yes.
Which is fine.
we fully agree, right there.
Okay, if you click on one feature, can we see the attributes related to this feature?
Let's see.
Well, so right. So if I'm clicking around on the map, right? So I'm clicking on the big purple shape, right? And it's displaying the attribute that I've told it to display, which is class. We're actually looking at this was something that in some user testing that we've done was a little confusing to some folks, but I think we're going to end up putting it back in where we display all the attributes of the thing that you're clicking on. And that's just, there's also an added thing that if we're viewing multiple data sets at the same time right now, the default behavior is like a core sample that happens. So it'll show you the values of all the things that you've clicked on. We happen only to be displaying one, plus the base tile, of course. But that's the decision that was made right now, and this is why the user testing phase is happening and why we're really serious about it. It's not just, we need to see how people are going to interact with this and what features they want.
So if we want to use this as a tool for talking to people about the impacts of climate change, how vegetation may shift, so what we can do is if you add a data set and search for climate again, this one, yes,
That one
add
right there?
that one. So what this is we went on and got data off of the global climate change models, and this is the predicted consequences of doubling of CO2 that would happen by between like 2077 and 2090.
Is it class?
2099. Yes, class.
Okay. Oh, did you want a value of it or just all unique?
No, just do all unique.
Okay.
Autumn palette on the bottom. So what this did is overlay what the vegetation would look like with this projected climate scenario. So if you click between the two layers, you can see the shift. So savanna lands are going to move down into where we have some forested regions. We're going to completely lose the desert section in the southwest. So yes, go ahead.
Oh, I didn't want to interrupt your sentence. I have a follow-up question.
Go ahead.
So this shows me how I can take data from one data set, graph it, take data from another data set, and also graph it. What I'd really love to do, for example, you know where I'm going with this, is I'd like to do, let's say, differences. Show me, let's pretend this is a temperature mapping. These are temperatures now, temperatures. I'd like to say temperature in this data set for this point minus data set here. Show me the deltas.
This isn't, that is a type of feature, and there's a few others. I actually thought you might be going in a slightly different, the question is, what you would like to see, what the questioner would like to see is, create new shapes, correct, I want to paraphrase what you've just said, but show me new shapes based on the change or the delta between the first data set and the second data set. So show me what the differences are as either new shapes or new type of data that gets generated. Is that?
Sure. I want to be able to operate, rather than just plotting the data sets on top of each other, I'd like to be able to do operations that actually use the data.
Yes.
Yes.
And that's one of the I'm sorry?
He wants a database join. He's just
A
shy to say
A database join, yes. And so there's a couple of answers. There's a couple of answers to your question right now. We definitely thought about that, and what we decided is that this tool right now, as we've built it, we call it affectionately GIS Lite. It's certainly doing a lot more than most GIS web-based tools can do in terms of pulling out shapes and just doing some query analysis stuff that we've done along single data set lines. And queries across multiple data sets is a feature that right now the answer that Tasha would give if she was talking to one of the grantees of Wilberforce talking about it is that's something you'd need to go into Esri or some other GIS software for. It certainly is a feature that we're keeping our ears to the ground on what we'd like to do. There's other features along data joining, which is the other comment that was sort of made about how you can take the results of one data set and, for example, fuse them to the concept of another, like show me this data by state or something like that. Those are also areas of research that we're very interested in, and we have some ideas for solution space. Other questions back there?
So say you are able to do calculations and just pull the shape files out and then go to the Esri products. Are you going to provide a way to then have that user ingest his calculations and have the attributes linked to this initial data set and so forth?
Yes. So the question is, thank you. So the question is, if somebody does take this out of these data sets, if they use the action button and get it downloaded into Esri, and they do some analysis based on it, and they want to upload it back into the system, do we provide that type of functionality? The answer is yes. Right now we do. We have an entire section of the site that's the import tool, basically, which I'll just jump into and just show you a little bit of. The idea here is that you can import any file that's sitting on your desktop that you want, and it's right now we're supporting specific formats, and we will be expanding those formats quite a bit over time. But in the beginning, right now, we're supporting Esri shapefile output, GeoTIFFs, and CSV as import formats. to Michael, I'll say we're KML, I hope, is soon on the heels. But the idea is that I can just browse to my desktop or anywhere, find a data set, amphibian habitats, which I just happen to have sitting around, and its output from Esri is in shapefile format. And I'll hit submit, and what it's doing is going and checking the data. And we've actually worked on a bunch of sort of user-friendly aspects along here. If the data set that I imported was in the wrong format or was in something that it didn't understand, it would actually try to give some feedback to the user to say, here's how you can correct this and go back, try again. Basically, we don't understand it. But what it did is it automatically took the XML file that was in the shapefile, zip file that I just uploaded that was in the FGDC format, and it pre-populated this data basically through this process. So as we walk through this phased process of importing data, you'll see that a lot of it has already been filled out for me. One of the nice features that for Esri and some of the other GIS packages is they do attach that XML file as part of their output, which is contains all that FGDC compliant sort of data. So we can go through this whole process, and I won't take up all of our time right now, but and just upload the data and have it go into the system. And part of this process that you'll have to forgive me, I'm sometimes more the sales guy than the engineer that has actually built it, but it is either there or very soon will be there, is to point to the data set that it's a derivative of. But it's up to the user to do that, because we have no control what they do to that data once it's outside of our system. And we have, and so you can basically say this is based on, and point to, do that same search that we were doing before and say it's based on this data that was in the system. We couldn't figure out a better way right now to enforce that because there's no way to know if it's a new data set that they're uploading or something that's based on something that we already know about under all circumstances. So I think that just in terms of timing and respecting everybody's time, it's great because we thought we'd leave questions at the end, but we've been getting them during, which is great. So what I'd like to do, I think, Tasha, was that about it on the demo side of things? Is just to jump very quickly and just sort of finish up our talk. And then we can take lots more questions if you want. We're here for the duration until somebody kicks us out, so let us know. I just wanted to just as a sort of wrap up, a conclusion of what we've been talking about. I don't need to read sentences to you that are up on the screen, but basically we're really passionate about public data. We are really passionate not just about the data itself and the tools that people use to visualize them, but about the concept of that data remaining in the public domain and out and available, so they can be used to generate better decisions. That people can use it for decision making or whatever purposes they have. And the information commons, we believe, is an architecture that helps us do that. It is built into the DNA of this architecture that information is public and shared and out there. It helps to prevent some of the erosion of the public domain that we've been seeing. And this database and site is the first example of one of our tools, on this community insight tool that is being used for the conservation science community that is really getting into some pretty deep and large amounts of data that are interesting to a specific community. And we're testing out a lot of things. I mean, some of the suggestions we've had here today, and I hope people will continue, go to the database and website, send us your feedback of other features you might want to see, because this is going to help us develop better tools that will help people in the conservation community. We've already had lots of inquiries from other communities in economic development and just many, many different areas of public policy that want to use this type of tool that have lots of distributed shared data sets. It wouldn't be fair if everyone's okay with this. We're also looking for help. And I say we, and I'm actually speaking more for the nonprofits that we work with. But basically, the major categories, I'll let you read them, but basically getting data into the information commons, you at Google, obviously, and some of the other folks who may be hearing this talk are sitting on lots and lots of data. And we would love to see some of that data flow in a way that is of use to these organizations that we work with. They need help with the data. They need funding to work with the data and understand it. And also, we need help spreading the word. We're a pretty small company out of Pittsburgh, and would love to work with Google Maps, for example, since we're using your tools to spread the word about innovative and cool ways that people can do that. And we do have, and we don't have to discuss them here, but a lot of our programmers and folks have a lot of requests and features that we'd love to see that we think would help some of the folks that we work with, both on the map side of things as well as the charting API that Google has. So that is, in fact, the end. And I'm more than happy to take any questions that people have. I just want to thank you all very much for coming out here today and giving us this opportunity. Yes?
I have several questions, but I'm going to just start with some of my most interesting ones. Oh, thank you. Do you have any plans to somehow connect with already existing conservation databases like NatureServe or Berkeley Natural History Museums or others? Because they may be less inclined, because they already have a system, to import into yours. So I'm wondering if there's any kind of cross-database joining that could happen where people could at least search for, if they're on the map and they want, you know, amphibian species or something, that they can just kind of tap that also and bring that in, or at least know that it's there.
So there's several answers to that question. Yes, we've been talking to lots of different organizations, and Tasha, you can talk about the politics side of it from a technical sort of aspect of things. In order for the data to flow and be searchable, you know, we allow geo-extent type searching, we allow keyword searching and different types of indexing that we do of the data. We need the data to sort of be, we need to get our hands on it a little bit, you know, and so we can index across it, for example. But we have, actually in the social services realm, we've actually done a lot of integration with, you know, Oracle database. You know, people have their data stores in Oracle, or there's even one that we're working with in FoxPro. You know, so you know, getting out into other people's data spaces and trying to help index that data in a way that our system is, you know, can make use of it. And I think that, and Tasha can talk about the politics side of it from, you know, from the conservation perspective, but I really feel that a lot of the systems that have been built in the past, where there are huge data stores, if you talk to the folks who are, you know, managing those and maybe, you know, trying to promulgate their usage, they're finding that just having a data store isn't really enough for this community specifically. And we're finding this a lot in the public sector. There's a lot of large piles of data sitting out there, and you know, and interesting database structures around them, which is great. That makes our job a lot easier if people have done that. But the usage in them and how people actually would use that information on a broader scale than perhaps the data was originally intended for, you know, for the one purpose that they've built that system for, that's the challenge. And we're trying to, once again, work within the public sector to make it easy for people to be able to get access to, you know, this type of system. Tasha, I do want to, I referenced you. I don't know if you have other comments on that front.
I just want to add, yes, that definitely I have been up to the museum, and we're working with NatureServe. I mean, it's a little tricky when you have, you know, groups with business models that, you know, they want you to pay for the information. So we're very new in the development of our partner engagement strategy, but absolutely. And because we're starting with a group of the Wilberforce grantees, we're going to really try to populate really quickly with the West and all the data we can get in a really rich geography, and a lot of data sets that really have this added value on them, like there's analysis been done. And so any ideas, other ideas you might have, I would love to talk with you further about that.
I have an inverse version of that question. Have you thought about exposing your maps as maplets so that other people could mash them up?
I'm looking over to Mike because maplet is specifically a term I've not heard, but the idea of any way that we, I mean, just as a general question, there will soon be APIs, for example, you know, so that people can directly query into database, and any way that we can get the data out of the commons into whatever visualization format or system you want is a very good thing. It's part of the model. It's exactly what we want to be. So if there are, Mike.
Yeah, so the intent is, and you know, not all of this is entirely built, but the intent is that a lot of the structures that you see in the site, you can make collections of data sets and things like that. You can expose all that stuff as RSS feeds, right? So you can follow along with that if you want to. Those, when we were going through the slideshow with the, you know, where you had taken snapshots and kind of embedded them in this slideshow, that embedding thing is going to be the progenitor of the feature, which is, hey, I want to embed, you know, the clip someplace else, right? You know, and do that kind of thing, right? You know, I think there's going to be some details to work out about how exactly it all fits together. But yes, we are enthusiastically in favor of people doing that. So yeah, that's the short answer.
Any other questions?
Save all mine to the end. So I can see when people are starting to upload and import their data that you're going to have a lot of replicate data. Right now, in my previous job, I got my data from the U.S. Forest Service, the California Department of Forestry, about a dozen of California or forest or some kind of vegetation databases, and I ended up with 4 different parks boundaries, all different.
Yes.
And so my question for you is, sometimes people want to be able to compare, sometimes they don't. It just confuses the issue. And so I'm wondering how you're going to address that, and also how you're going to deal with replicate data if the Park Service wants to put their borders in, but the California department doesn't, or does, and then you have 2. So I'm just wondering how you're going to address that.
So from a policy side of things, and maybe Mike, I don't know if you want to take the technical answer to it, but from the policy side of it, the Information Commons as a platform, part of the concept is that you need to allow conflicting data. It's very important. There is no overall agenda. There is no right data. It's right in the eyes of the beholder, basically. That said, we are actively in the process of working with experts in the field to sort of publish in an open marketplace, which is in the Commons, assertions about what is correct and what isn't. And you can decide whether you believe that or want to subscribe to it or not. At a deeper technical level, we've been doing a lot of work around things like shape fusion, so that if you get a park that you then all of a sudden get along one boundary because you've got a data file that is a river, that is one border of that park as a definition, and that border happens to be higher resolution than the rest of the shape that you have. Because of the data model, the object model, the way we store things, we can actually replace, create a definitive shape that is the park as a concept, and then start publishing assertions against it. That is obviously fairly high level or low level, I'm not sure which, but it's a pretty complicated operation to have. And for this project, we decided not to tackle it at a first pass. But it is absolutely areas of research that we've done a bunch of research on, and there's still a ways to go. I mean, there's no definitive answer to your question, obviously. Mike, I don't know if I did an okay enough job on that.
Yeah, I think you did. Is this on?
Yeah.
Yeah. So just from a technical perspective, I think the nearer term answer is to provide some simple kind of data fusion, data joining operations that other people were talking about that lets you kind of merge some things. Obviously, with geospatial stuff, that's more complex, and I think the geospatial fusion is probably longer term. As Josh said, we have some previous research on that, but honestly, one of the reasons it doesn't appear yet in this site is because it needs, I think, some more work before it's really ready, right? That said, it's pretty cool. So, we'd love to do it, and we're enthusiastic about it. I think if in the nearer term, what we're going to try to do is make it easy for people to sort and filter and create reputations around different data sets, different data objects, different publishers of data and stuff like that, right? Yeah, popularity, that sort of thing. So hopefully that will let people do a little bit of the sorting and the finding on their own organically. But it's one of those things that kind of, it's a chicken and egg problem, right? Until we've got enough of the community built to sort of make that happen, you kind of need to seed it a bit. So that's part of what Tasha and CBI
It's worth noting that for the software that we build, anyway, as Ryza, every node, basically, so a community, like Database is an example of a community insight installation. If there is others, for example, an economic development one that somebody else does, or and other nodes start coming online, they have the ability to share information across those nodes seamlessly, and that's where you really start running into the issues of wanting to be able to know what is the definitive what is the definition of this boundary of this area, and so we know we're tumbling quickly towards those issues, and hopefully we'll be able to address them soon. Other questions?
I have one more.
That's great.
So just a quick comment about the earlier discussion about the professor versus the staff scientist. I think, and why the postdoc was a new persona for you. I think the thing that was left out of that conversation is just where their career or their level of comfort with technology falls and where the technology is going and how it's changed over the years. And you'll have, brilliant professors who use Excel for everything, and then you'll have postdocs who are starting to say, well, I know about these Web 2.0 applications, and we can get it out there. And the professors are in support of that. They just don't know about it or know how to use it or are uncomfortable with it or whatever. And so I think there's that, which kind of leads into my question. How, when you have these different players, these different types of people importing data, how are you going, and I saw that form in there, but there's going to be more to it, how to standardize or how to, right? I mean, there's going to be ways where you're going to have the data standardized in some way so that it fits in with your system the way it's built. And so I'm wondering, besides just the upload, and so I'm wondering how you're going to deal with that, I guess. And also, yeah, I guess that's my whole question. Thank you.
Mike, do you want to take it?
Well, as far as, I feel like maybe there's something lurking behind your question that I didn't quite get. I mean,
I guess my question is, what if my mother wants to upload something?
Right, okay. So
versus a professor versus a postdoc, different levels of
technical
science
expertise.
And different levels of technical.
Yeah, so I think right now, the added part of the question was, what if my mom wants to upload data into the system, right? And yeah, the import part of the system is scarier than the rest of the system, and it uses there's lingo like WGS84 and FGDC and lots of fields and stuff like that are kind of, a little bit of a pain, One thing that you can do is you can upload very sort of simple structured data like CSV files. One of the little features that fell on the floor that I'd like to put back in is, just putting a form field where you can cut and paste something that you copied out of Excel or whatever in there, and it would parse it out for you, right? This appears in some other systems like, if you go look at Many Eyes or Swivel or whatever, other people have done things like this. I think, yeah, the import process right now is very geared to the taste, quite frankly, of our partners over here, right? Because right now, they're shouldering the heavy lifting of getting the kind of snowball rolling. But I don't think we will have really succeeded until we can capture a broader spectrum of people who, who can do more of that and can do that sort of lighter weight, more casual uploading. I think this also, oddly enough, gets back again to the question of data joining and data fusion, right? So if you're going to upload something from a CSV file, it's not going to intrinsically have a lot of geospatial interest to it, right? But if you can put a column in the CSV file that's, state names or, some reference to some other data set, right? Then you can do that sort of fusion in, and you can kind of attach those, to another data set, right? So how do you want to manage that while still preserving the autonomy and independence of the data sets? There's some questions there, right?
I would just like to add, we also recognize, I came from, before I joined Conservation Biology Institute, a big NGO that really does care about sharing data, but no one has time. And so, us coming and saying, oh, you should spend your valuable time uploading data to our, this system, we recognize that that's just never going to make it to the top of their priority list. So that's why we're really trying to develop, funding strategies and stuff so that we're actually coming to them and saying, okay, look, we'll come, and if you just give us the information, we'll actually, be added value for you.
That's the data SWAT team thing that's up there, by the way.
Yeah.
Thanks, everybody, for coming. I think we're going to cut questions off, but please feel free to come up afterwards and join us for discussion.
Well, thank you all very much, and Michael,
Yeah,
thank you for
thank
organizing
you.
this. Thanks.